This is a brief introduction to BCA tables. So taking a look at the problem, we have how many grams of water can be produced from the combustion of 32 grams of methane, CH4, and 32 grams of oxygen. I have the balanced equation already written out and ready to go, and oftentimes people from this point would go ahead and start doing some type of factor label method and getting the answers and comparing them to do limiting reactants, etc. But if we're doing a BCA table, what we have is a BCA, which stands for before, change, and after. Now this entire table needs to be filled in with moles, or at least that's what I tell students initially. From this point you could actually do this with liters of gases as long as they're at the same temperature and pressure, but for now we're just going to be looking at this from the concept of moles. So we know that at the very beginning of the reaction there is 0 moles of CO2 and H2O, because that's at the start, the reaction hasn't started yet. Then I need to figure out the number of moles of both the oxygen and the methane. If I were to go ahead and do that, I determine you can do that on the side, you can show that as a separate problem, but 32 grams of oxygen is going to be 1.00 moles, and we have the molar mass of methane is 16, so we end up with 2 moles, 0.00 moles of methane. Now from here it's just a matter of trying to figure out, okay, well, if this reaction takes place, these things are going to go down, these things are going to go up. So this is going to be plus and a plus, this is going to be minus and minus. So now I just have to figure out which one of these two is going to be the limiting reactant. And I've seen a few different people do this in a different way. Here's the method that I like. I take the number of moles, at least with students anyway, I take the number of moles and I divide it by the coefficient that happens to be next to each of these substances. So if I've got 2 moles divided by 1, I have 2. If I've got 1 divided by 2, I've got 0.5. So now I have these two numbers to compare. Since I know that this 0.5 is smaller than the 2, I know that the oxygen is going to run out first. Other people have looked at it and said, well, now you can look at the mole-to-mole ratios and compare these and see how that works. There's a bunch of different ways of going about explaining it. That said, we now know that this is the limiting reactant. So the 0.5 times 1 means that this is going to lose 0.5 moles. This one is going to lose 0.5 times 2, which is 1.00 moles. The 0.5 times 1 is going to be, this means it's going to go up by 0.5 moles. 0.5 times 2, this is going to go up by 1.00 moles. And then you just do the math of addition and subtraction. So you have 1.50 moles here, 0 moles of oxygen, 0.5 moles of carbon dioxide, and 1 mole of the H2O. Now, based on the question itself, I then have to take the 1 mole of H2O and convert that into grams based on the fact that the problem asked for the mass. So, and you would then do that separate calculation of 1 mole, H2O, 18 grams of H2O for every 1 mole, H2O, and you end up with an answer at the very end of 18 grams of water. Great. But aside from the fact that I have the answer for the products, I can actually go back through and look at this in a much more detailed fashion. I could say, well, how many moles of methane are used? How many moles of methane are left? How many moles of oxygen get used? And you can also drive home the point from a conceptual standpoint of one of these two reactants has to go to 0. There's always going to be one that drains down to 0 and stops. That's what's going to stop the reaction itself. You can see then exactly how much of each of the products are going to be made, and everything is laid out in moles. Granted, it is in moles, so everything has to be converted into moles before you're able to use the table itself. But usually students don't have too much of a problem of going from mass into moles, or going from moles back into mass, or what have you. So this ends up being a nice way of doing this. Please let me know if you have any questions.